All right, in 58C, I've got a two-vector valued function, get out of your hand, of two variables. And the first component has a square root, the second component has a natural log. This is not going to be a linear function, of course, but the natural domain convention that you knew from before gets extended here so that the codomain is R2, the collection of all two vectors. That is, everything that comes out of this function will be a two-vector. And the domain is the ordered pairs of numbers x, y, so the ordered pairs of numbers x, y, and R2 being all of the ordered pairs of numbers, but only the ones that satisfy these two conditions. The thing underneath the square root needs to be non-negative, greater than or equal to 0, and the thing inside the natural logarithm needs to be strictly greater than 0. Okay, so both of those things need to be true. I've rearranged this algebraic inequality to simply this. Now that describes the interior of an ellipse with eccentricities 2, that's the square root of 4 there, and 1. So the eccentricity is 2 horizontally and 1 vertically. And that stinking little line over there, that was me about to draw a circle instead of an ellipse. Sorry about that. Okay, and then this other one right here that says y needs to be less than x, so I can draw the line y is equal to x. I draw it dotted because this is a strict inequality that is less than, not less than or equal to. So dotted line, and a shade below it because y values need to be smaller than that. Or you could think that you're shading to the right of it because x needs to be bigger. Now, the place where both of these conditions are met, I'm going to shade that in red. So both in the green shaded region and in the blue shaded region, that's going to be this region. And it will include the boundary over here, so I'll redraw that boundary in red. But it will not include this boundary where we had a dashed blue line, so I'll make a dashed red line on top of the dashed blue line. Okay, and that would be the domain of this function. That is the natural domain of this function, i.e. the domain of the algebraic expression here, the two-component algebraic expression through the natural domain convention. Certainly someone could say that there's a different domain. They could say it's only the top half of this red region, say, the part above the horizontal axis. You could do that. But the natural domain convention is, if only the rule of correspondence is given, and it's given algebraically, then take the biggest domain consistent with having only real numbers as outputs, or in this case, ordered pairs of real numbers.